Hi, I'm an old guy and I do maths, and I do quite a bit of differentiating. And I quite often use the product and the quotient rules. And um, I was reminded of this again this morning when I was doing some work involving both of these rules, and how rarely I use this form of the rule because I find it less memorable and a little bit clunkier to work with. So what I use is it's a slightly different notation. It's nothing more than that. So if we look at the product rule, what we're doing is we're splitting a function up into two parts. And that is because one part of the function is multiplying another part of the function. And we split those up into parts u and v. And u times v is equal to y. So dy dx is equal to u, the first part of the function, times the derivative of the second part of the function. So let me give you a quick example of what I'm talking about. Something like that. This would be u and this would be v. Now, there's another way of writing this that I think is easier to remember. And because it's easier to remember, I find it easier to work with. So I'm just going to go through this. Instead of calling things u and v, I call things f and g. It's not a big deal. And what that allows me to do is to write this rule out with a more compact notation, which is easier, as I say, to remember. So dy dx is equal to f times the derivative of g dash, or g prime, however you want to call it, plus g times the derivative of f, and that's it. It's nice and fast. It's easy to remember. Now, the other part of this video is about the quotient rule, which I've got down here. And something similar goes on here. Again, dy dx, y is comprised of u and v, those two parts. Now, an example of that might be if we take this x squared minus 1 and we pop it over 3x squared plus x, and we decide we're going to differentiate that. That's u, that's v, and we go through this this formula here. Order is not terribly important when it comes to the product rule because we're multiplying and adding. Order is important here because we are subtracting. So it's v du on dx minus u dv on dx all over v squared. Now, we can abbreviate that into something that, again, maybe is just easier to remember and slightly easier to work with. So, it's the differential of f times g. So I've just put this in alphabetical order, but that's the differential of f there, the differential of u, and that's g, v. So that's f, that's g, minus g prime, the differential of g, times f. There's f, there's g, the derivative of g, all over v squared, all over g squared. That and that are easy to remember. It's up here that people struggle. So anyway, that's it for what it's worth. As I say, I was using this form this morning, and I just recalled how easy it was compared with the other form. Anyway, it's out there. If you found this useful, please like and subscribe. I should mention that this does appear in textbooks, but it's always as a kind of aside, and it's the two principal formulas that you're used to that that the books tend to emphasize. Okay, I'll see you next time. Bye.